Okay, here it goes. Okay, this is what we're doing today and some more next time in general. We're going to be studying in a lot of ways f prime and f prime, because f prime and f prime tell you just about anything you want to know about f. And so that's what we're going to be working on all hour, and then we're going to continue that next time. So we're going to be investigating f prime and f double prime to find several important features on the graph of f. Okay, so here's what I want you to do. I want you to label all of these as being f of x. It's very important, because by the end of the hour, these are no longer going to be f of x. They're going to be f prime. So I want you to make sure that when you look back at your notes, you understand that these are all f of x. Got it? All of them. Okay, so what do you notice here? What I did here is I drew a bunch of pieces of a function, and I also drew little tangent lines. You see the little tangent lines that I drew along the curve? That's important for you to look at as well. So as you look at these first two graphs right here, do you agree that I've drawn f of x increasing? And again, when I'm talking increasing and decreasing, I'm always talking left to right. So do you agree that I've drawn graphs of f that are increasing from left to right? All right. So what else do you notice here? When you look at all these slopes, look at those slopes, look at these slopes. What do you notice about all those slopes? They are all what? Positive. And so anytime the derivatives or slopes are positive, f will be what? Increasing, and vice versa as well, right? All right, let's look at these next two graphs. Do you agree I've got graphs here of f that are decreasing? Yes or no? And notice I've drawn these little slopes as well along the curve, these little tangent lines. So you can look at the slopes of those tangent lines. So do you agree in both these graphs f is decreasing? And what do you notice about all the slopes or derivatives? They're all what? Negative, aren't they? They're all negative, or in other words, less than 0. Okay? So anytime the derivative is negative, f will be what? Decreasing, and vice versa, right? Okay, now, here I drew a little bit bigger picture. All right, what's happening here with f? F increases and then suddenly what? Decreases. Okay? And so what do you notice about the slopes here? The slopes here are positive, and then all of a sudden they're what? Negative. And by the way, at the top of the hill, the slope is what? 0. So, here's what I want you to get out of that graph. When will f change from increasing to decreasing? Whenever the derivatives or slopes change from what? Positive to negative. Do you agree with that? Yes? Okay, so what happens here is, since f prime changes from positive to negative, that causes f to change from increasing to decreasing, causing f to have a hill. And what do we call hills? Local maximums or relative maximums. Got it? Okay? And by the way, again, at the top of the hill, the slope is what? 0. Okay. What's happening here with f? F decreases, and then it what? Increases. So here f is changing from decreasing to increasing, isn't it? And what do you notice about the slopes here? These slopes are all negative, then all of a sudden they're what? Positive. So f will change from decreasing to increasing whenever the derivative, or f prime, changes from negative to positive, won't it? And by the way, when all this happens, what else happens? That creates a what? A valley, which we call a what? Local minimum or relative minimum. Got it? Okay. And again, at the bottom of the valley, just note that the derivative is what? 0. Okay? Stay with me. Yash, with me? All right. All right, again, I want you to circle the fact that this is f. And again, you'll see why by the end of the hour. You'll see why I'm stressing that so much. Okay, so if you're looking at a graph of f now, I want you to notice something here. On what intervals is f increasing, guys? F is increasing on what intervals? Well, from here to here, you agree f is increasing from there to there? Yes? And by the way, all the slopes in there are what? Positive. Where else is f increasing? Well, from here to here, isn't it? Yes? And again, what do you notice about all the slopes if you drew a bunch of little tangent lines All the slopes would be what? Positive. All right, so if I asked you to tell me what intervals is f increasing, isn't that what you'd give me for the answer then? On the interval -4 to 0, and then again from what? 3 to what? 5. And notice, see how they're all rounded on the ends? You never include the endpoints when you're doing something like this, because we only want to talk about what's happening between the x values on something like this. So never use square brackets on these. Okay? Is that clear? Okay. All right, on what intervals is f decreasing, guys? Well, f is decreasing here, f is decreasing here, and f is decreasing here. Everybody agree with that? Okay, so what intervals are those then? What intervals are those? -∞ to -4, where else? 0 to 3, and then what? 5 to, looks like infinity, assuming this keeps going, yes? Following me? And again, anytime f is decreasing, what about the slope or derivative? The slopes are what? Negative. Do you notice that? That the slopes, if you drew tangent lines on all of those curves, all those pieces of the curve, you'd have negative tangent lines, negative slope tangent lines. Everybody agree? Okay. By the way, where does f have a local max? Where does f have a local max? Here and here. And just because there's a sharp turn doesn't mean you can't have a local max. You certainly can. And so do you agree that local maxes are at 0 comma something and 5 comma something? Agree with that? Okay. Where does f have a local min or valley, guys? Wouldn't that only be here? Yeah, so at -4. Okay, other notes. Where's the derivative 0, guys? Quick. Where's the derivative 0? At -4 and at what? 0. Where is f prime undefined? Where? At 3, because f is undefined. And where else? At 5, because there's a what? Sharp turn. Is that clear? Okay, so again, where are your hills and valleys possibly going to occur then? Whenever f prime is what again? 0 or undefined. Is that clear? And aren't those also the spots where f might change from increasing to decreasing or vice versa? Yes? By the way, my mic is on, right? You can hear it? Yeah. Okay, okay. All right, now, you guys, so based on everything you see here, based on all of this stuff here, you should now be able to basically describe the steps without me even giving it to you. So what I'm saying is, even though I'm presenting this as a step-by-step process, if you really understand what I did here, this should be common sense. This is not something you should need to study to remember. You should not. It should all make sense. And once I go through it, it should be in here permanently, because it should make sense. If you're trying to memorize, it's not going to stick very long, is it? But if you understand and think about where things come from, this should be easy to remember, and it should make sense. Okay, ready, guys? Okay, so here's what we're going to be doing for pretty much most of the hour today. Ready? We're going to be finding intervals where f is increasing and decreasing. And from there, won't we be able to pick out our hills or valleys, which are our local mins and maxes? Right? And so where do you think you would start then to find something like this? Where do you think you would start? By what? Finding the what? The derivative. Yes? And you want to factor it. Why would I want to factor it? So that I can what? Find where the derivative is what? 0 or what? Undefined. Okay. Now here's what's going to be kind of new and different. Once you find and factor the derivative and pick out where the derivative is 0 or undefined, you're going to use those x values to do what? To what? Break up the number line into what? Test intervals. So you can kind of see what's happening. Got it? Okay, you'll see what I mean in a minute. And then what? Well, again, what I want you to do is I want you to pick any nice test value you want in each interval, put it into f prime to see if f prime is positive or negative. And why would you want to do that? Because that'll tell you what f is doing on those intervals. In other words, if f prime is positive on an interval, what can you say about f on that interval? It's increasing. If f prime is negative on an interval, what can you say about f on that interval? It's decreasing. Do you see why I'm doing this? Okay? And so that's step 4, just to use step 3 to tell whether f would be increasing or decreasing on each interval. And then finally, once you have that, won't you be able to pick out your hills and valleys, which are your what? Local mins and maxes. Okay, so again, doesn't this make sense? Okay, so there really should not be any memorizing here. That's when students get in trouble, and that's when they start mixing things up, when they try and memorize everything. Those days are over. No more memorizing in math. Okay. Okay, so here we go. Now again, you guys, I was nice enough to type all this out. You don't have to fill anything in. All you got to do is watch and stay awake, please. Okay, here we go. All right, so here's what the problems are going to look like on most of your assignment tonight. I'm going to give you a function, f of x, and I'm going to say, find the intervals on which that function is increasing and which it's decreasing, and then use that information to find where f has any what? Local mins and local maxes. Are you clear in what we're doing here? All right, so here's what you're going to do. What are you going to do first? Find the derivative, right? And factor it. So everybody, quick, what's the derivative? Quick, quick, quick. 3x squared minus 6x minus 9, and then I can pull out a 3, and then I can try and factor what's left, and sure enough it factors. So does everybody agree that that's my factor derivative? Okay, everybody look at that and tell me, where is that derivative, 0 or undefined? Quick. Where? At -1 and 3. Okay, with me so far? All right, now here's the new part, the tricky part. What am I going to do with those numbers? Well, notice, did I give you an interval? Did I give you an interval? No, so guess what? You're going to have to use the whole number line from -infinity to infinity. Is that clear? All right, so here's what you're going to do. Start with -infinity, and what's the first one of those two numbers that I run into? Which one do I run into first? -1. So I'm going to go from -infinity to -1, and then I'm going to pick up at -1 and go to what? What do I run into next? 3. And then I'm going to pick up at 3 and obviously go to what? Infinity. Are you following me? All right, now what you're going to do next is you're going to pick anything you want in each of these intervals. So for example, in that interval, I'm going to pick something, anything I want. Keep it small and simple and easy to work with. So what's a nice, easy number to work with between -infinity and -1? -2. What's a nice value in there? 0. What's a nice small value in there? 4. Notice how you never pick the endpoints, right? Because these are open intervals. Is that clear? Okay, never pick the endpoint. Is that clear? All right, now watch. Watch what I'm going to do, please, because I didn't explain this. I just kind of did it and wrote it down. So everybody watch. What I want you to do is I want you to pick that value, -2, and put it into f prime. So if I stick a -2 there and a -2 there, I don't want a value. I just want you to quickly determine if that product would be positive or negative. Always stick it into the factor derivative, always. That's the easiest place to put it. So just imagine putting a -2 there and a -2 there. Ready? What would I have? If I stick a -2 there, this is negative, times, let's see, if I stick a -2 there, that's another negative. So what's a negative times a negative times a positive 3? Positive. Okay? All right. Now I'll tell you right now, if f prime is positive at the test value, it'll be positive at every value on that interval. Is that clear? So that's why you only have to pick one and test it. Okay, so since I determined f prime is positive on that interval, what can you tell me about f on that interval? It's what? Increasing. So basically, I mean, you don't need these other tables. I just kind of was trying to show you slowly what I was doing. But really, all you need is this one table, okay? For each problem on your homework, you need one of these tables. Got it? Yes? So again, everybody see what I did? I picked a value like -2, plugged it in f prime, determined it was positive without a calculator. And since f prime is positive on that interval, I can say f is what? Increasing on that interval. Got it? And just keep doing this. What did I pick in here, guys? Maybe 0? Okay, stick a 0 where? Into f prime, into the factored form. If I stick a 0 there and a 0 there, I don't want a value. I just want to know whether the whole thing is positive or negative. So if I stick a 0 there, this is what? negative. If I stick a 0 there, that's positive. So I got a negative times a positive, which is a what? Negative. Everybody agree f prime is negative on that interval? And so what can you say about f on that interval? It's what? If f prime is negative, isn't f decreasing? Okay. Okay, how about here? We picked 4, didn't we? If I stick a 4 there and a 4 there, what do I have? Positive times a positive, which is a what? Positive. With me? Hi, G, you with me? Yes? Okay. And so, if f prime is positive on that interval, what can you say about f on that interval? It's increasing. All right, are you with me? All right, so now we're ready to finish it up. Ready? Okay, I want to know. Actually, I'll start down here. So look at my table, guys. On what intervals here is f increasing? Well, wouldn't it be here and here? And so what are those intervals? What are those intervals? Negative infinity to negative 1 and what? 3 to infinity. So f is increasing on those intervals. Everybody agree? Okay? Okay, look at your table. On what interval is f decreasing? Where? Where? Negative 1, 2, 3. Okay, so far, guys, you see what I'm doing? All right, now I also want to pick out the hills and valleys, which are my local mins and maxes. Are you ready? Okay, heads up. Okay, heads up. Look up here. Thank you. Okay, so here we go. So, you guys, what's happening right here? What's happening right here? F goes from what? Increasing to what? Decreasing, causing a what? A hill? And so can't you say that it looks like f has a hill or a local max at what? At negative 1 comma something? Isn't this negative 1 here where these two intervals come together at negative 1? Yes? So it looks like f has a local max at negative 1. Now where am I going to put that to get the y value on f? Clearly I'm going to put it into the original function f of x. So if I stick a negative 1 in here, what do I get? Well, I end up with a 5, actually. So there you go, then. So f has a local max at what? Negative 1 comma 5. Okay. Now, what's happening here, guys? What's happening here? Looks like f changes from what? Decreasing to what? Increasing, causing a valley or a local min at what? X equals what? 3? Yes? So it looks like f will have a local min at 3 comma something. And where do I get the y value from? Plug it into where? Into the original function. So if you plug 3 into original function, what do you get? Negative 27. So there you go. So f does have a local min at 3, negative 27. All right, now don't turn the page. Let me ask you something. What if I stuck that 3 into f of x and it was undefined? Then what? Then what? Would there be a local min there? No. There has to be a point before you can have a local min, right? And so what would actually be happening there? Instead of a valley, it would probably just be a what? Asymptote or a hole, maybe? Right? Does that make sense? And so that's what I'm getting at right here. Because suppose your graph of f looked like this. Isn't f changing from increasing to decreasing? Maybe making you think that there's a hill there, but is there a hill there? No. There's a what? Asymptote. So in a problem like that, the table might be misleading, right? And actually there is no local max there, is there? So just watch out for that. Is that clear? That's why it's important for you to plug those x values into f to make sure there's even a point there. Is that clear? Okay. All right, next one. All right, I know you all know the quotient rule, so I'm not going to ask you to help me. I'm just going to go ahead and do it. Ready? Everybody agree, though, I do need the quotient rule to find the derivative here, so here it goes. Derivative of the first function times the second function minus in brackets the first function times the derivative of the second function all over the second function squared. Are we good on that? Okay, simplifying this, don't I distribute the 2x here and here? 2x squared minus 2x minus x squared. And then shouldn't I combine those into a x squared? And I should probably pull out an x on top. Everybody agree with that? Okay. All right, so everybody agree that that's my factored derivative? Everybody agree with that? Okay. Good? Can I take that down now? Is that okay? I mean, it's just the quotient rule. You guys know that already, right? Okay. All right, so let me just write that down here. So x times x minus 2 over x minus 1 quantity squared. Okay, so there's my derivative. All right, now, from there, what am I going to do next, guys? You tell me. Find where the derivative is what? 0 or undefined. And what would that be? Where? Quick. 0, 2, and 1. Everybody agree those are my three values that I have to use to break up my number line into test intervals? Because those are all the places where the derivative is either 0 or undefined. Good? Okay, so here we go. All right, so I'm going to start with negative infinity. What's the first one of those three that I would run into? 0. So I go from negative infinity to 0. That's one interval. And then I pick up at 0 and go to what? Which one do I run into next? 1. And then I pick up at 1, and then I run into what? 2. And then I pick up at 2 and go to what? Infinity. Following me? All right, pick anything you want in these intervals. Ready? Eric, you all right? You okay? Okay. Okay, so real quick, anybody, pick anything in here, something real small and easy to work with. Negative 1. Pick something in here. 1/2. 0.5. Okay, 0.5 is easy to work with if I have to pick a decimal, right? 1.5. Thank you. How about here? 3. Okay, here we go. Where are we going to put these? We're going to put these into f prime because that'll tell me whether f is increasing or decreasing, won't it? Yes? Okay, and again, I want to see these labels on your tables. I don't want you skimping on your tables because you know if I check the homework or if I grade certain problems on the test, I'm going to be looking for all the details. Don't skimp on my table. Make sure you label what you're doing in the table. Without that, is the table going to make any sense? Without that? No. Okay, so make sure you label these. All right, so what I'm going to do now is I'm going to stick that into f prime. Ready? Now again, I don't want you reaching for a calculator, and I don't want exact values. I just want to know whether f prime is positive or negative at all these test values. Are you ready? All right, now look, study the derivative for a minute. Notice, isn't the denominator squared? So no matter what I stick in for x, once I square this, won't the denominator always be positive? So do I even have to worry about the bottom? No. So just stick a negative 1 there and a negative 1 there and tell me whether the numerator would be positive or negative. Quick. Well, let's see. I have a negative. If I stick a negative 1 in there, minus 2 is negative. Negative times a negative is a what? Positive. Everybody agree that f prime is positive there on that interval? And if f prime is positive on that interval, what can you say about f on that interval? It's what? Increasing. Okay. Okay, stick a 0.5 there and a 0.5 there. Quick, quick, quick. Is f prime positive or negative? Well, let's see. Positive times, if I stick a 0.5 there, minus 2, that's negative. So a negative times a positive 0.5 is a negative. Everybody agree? And if f prime is negative on that interval, what can you tell me about f? It's decreasing. Okay, stick a 1.5 there and a 1.5 there. Quick, quick, quick. Positive or negative? Everybody agree it's negative? Okay, and if f prime, I should say, is negative on that interval, what can you say about f on that interval? It's what? Decreasing. Okay, stick a 3 in there and a 3 in there. Quick, is f prime positive or negative at 3? Quick. What is it? Positive. And if f prime is positive on that interval, what can you say about f on that interval? It's what? It's what? Increase. Okay. All right, so are you ready? All right, let's start with these at the bottom. Looking at your table, somebody tell me, at what intervals is f increasing? Quick. From negative infinity to what? 0, and where else? 2 to infinity. Everybody agree with that? Yes? Okay, at what intervals is f decreasing? 0 to 1, and what? 1 to 2. Okay? All right, now what? Well, now let's study what's happening here. F goes from what? Increasing to what? Decreasing where? At x equals what? 0. And so that would cause a what? Hill at x equals 0? Yes? And what are the hills called? Local maxes. So you have a f has a local max at 0 comma something, right? And if I want the y value, how would I find that? Put it into where? Into the original. Isn't this a point on f? So if you stick 0 into there and 0 into there, what do I get for the y value? Quick. Everybody agree it's 0? So at 0 comma 0. All right. Now, what's happening here? Well, f goes from decreasing to what? Decreasing again. So if f decreases and then decreases again, is there a hill or valley here at 1? Nothing, right? Nothing's at 1, not a hill, not a valley, right? All right, what about over here? F goes from what? Decreasing to what? Increasing at what? X equals 2. And so that would be a valley, wouldn't it? Looks like there would be a valley maybe at 2 comma something. What are the valleys called? What are the valleys called? Local or relative mins. So it looks like there's a local or relative min at 2 comma something. And how do I get the y value? Plug it into the original. So if I stick a 2 there, that gives me 4 over what? 1, which is 4. Does everybody see what we're doing here? Yes? All right. Now we're going to do the same thing on the next 2 examples, but the math is going to be a little bit harder because now we're going to have to deal with a what? Exponential function. It's not bad, though. It's not bad. It's trickier, but it's not like it's a lot more work or anything. In fact, it's actually a little bit less work. Are you ready? Okay, so here we go. Okay. Again, I don't want to cram it in there, so let me find the derivative on a separate piece of paper, okay? All right, so I've got, what do I got for the function? F of x equals x squared e to the x. How am I going to find the derivative of this, guys? Don't I have to use the product rule? Because you're looking at a product where both factors have a variable, so I must use the product rule? Okay, so here it goes. Derivative of the first times the second plus the first times the derivative of the second. What's the derivative of e to the x? E to the x. All right, so, all right, is there anything I can factor out here? I can pull out a what? I can pull out a x and a what? E to the x, and what does that leave me with? 2 plus x. Everybody agree that that's my factored derivative? Are you following me on this? All right, now hold on a minute. I'm going to now pick out where f prime might be 0 or undefined. Are you ready? You with me? Chris, with me? Yeah. Okay. Well, I'll tell you right now. For that thing right there, you're going to need to draw a rough sketch. And by the way, I checked your homework last time, and on one of the problems it asked you to use a sketch of this to answer some questions, and probably 7 or 8 of you had the wrong sketch for e to the x. You guys can't be making that mistake. You should all know by now what the graph of y equals e to the x looks like. What does it look like? E to the 0 is what? 1. And then doesn't it rise from left to right like that? And isn't there an asymptote on the x-axis? So, all right. You can't, you guys, I'm not sure you appreciate how valuable that graph is on a problem like this. Because now you can look at that and see it's never 0. Is this ever 0? Does it ever hit the x-axis? No. So that's never 0. So what I'm saying is this is not going to give us any x values where the derivative is 0, is it? Not only does it tell you that, but it tells you something else also very important. What do you notice? It's always where? Above the x-axis. In other words, that is always what? Positive. Isn't that going to come in handy in a minute when I'm trying to figure out where the derivative is positive or negative? Isn't that going to be very, very, very valuable to know? Yeah. So you see why you absolutely must know what that looks like? Yes? Am I too loud on the speaker? No? All right, anyway. I apologize if I am. Okay. All right, so back to the problem. Ready? Here we go. So can I just copy that down, guys? Is that okay with you? All right. And by the way, I'll make that note that this is always what? Positive. Okay. Make that note. Okay, so here we go. Okay, so now look at that, guys. You should all be able to tell me where this product is 0 or undefined. Where? At where? 0 and -2. Everybody agree with me on that? Yes? Okay, so now I'm going to make my test interval. So I start with -infinity. What's the first number I run into, guys? -2. And then obviously I pick up at -2 and I go to what? 0. And then I pick up at 0 and go to what? Infinity. Are you following me, guys? Okay? All right, so now pick anything you want in here. Make it small and easy to work with. -3, pick something in here. -1, pick something in here. 1, okay. Are you ready? Okay, if I stick a -3 into my f prime, again, I don't want a value. I just want to know whether it's positive or negative. And again, I can ignore this part, can't I? Because that's always positive no matter what x is. So if I stick a -3 there and a -3 there, let's see, that gives me a negative here times a negative here. The whole thing is what? Positive. And if f prime is positive on an interval, what can you say about f on that interval? It's what? Increasing. Okay. Stick a -1 here and a -1 here. Let's see, that gives me a negative times a positive, which is a what? Negative. And if f prime is negative on an interval, what can you say about f on that interval? It's decreasing. Okay, now put the test value 1 in here and a 1 in here. If I put a 1 here and a 1 in here, let's see, a positive times a positive, which is a positive. And if f prime is positive on an interval, what can you say about f on that interval? It's what? It's what? Increasing. Thank you. Increasing. Okay. All right, so we're ready to answer the questions now. Ready? The questions were, on what interval is f increasing? Let's start with that one. Look at it. What are the intervals? -infinity to -2, and where else? And where else? 0 to what? Infinity. Is everybody okay with that? Yes? Should be writing these down. Everybody writing these down? Okay, on what intervals is f decreasing, guys? -2 to 0, yes? Okay, now, what's happening here, guys? F goes from what? Increasing to what? Decreasing where? At x equals -2? And so that would be a hill, wouldn't it? So it looks like f has a hill or a local max at what? At what? -2 comma something? And how do I get the y value? Put it into the original function. So if I put a -2 into here, what do I get? Quick. You can do it in your head. What do I get? 4 times e to the -2, which is the same as 4 over e squared. So 4 over e squared is the y value there. Everybody agree with that? Yes? All right. What's happening here, guys? F goes from what? Decreasing to what? Increasing. So that would be a valley maybe, possibly. Yes? Okay? Okay. All right, so that looks like that would be a local min, right? At what? At 0 comma something, yes? And so if you stick 0 into the original function, what do you get? Everybody agree you get 0? Because you get 0 squared times e to the 0. What's e to the 0? 1. What's 1 times 0? 0. Any questions? All right, hold on. Wait. Wait. I should have done this earlier. And by the way, since you don't have the even answers, this is a real quick way you should be checking this on your homework tonight. In fact, I should do this anyway, just so you appreciate what we're doing. Okay, ready? Watch this. I'm going to graph the original function. Here it is. Okay, I'm just going to hit Zoom Z standard. And let me actually use a smaller window. Let's try the decimal window. Okay. All right, so what do you think, guys? Look at what we found out. Does it look like f is increasing from negative infinity to negative 2? Yes. Does it look like f is decreasing from negative 2 here to 0? Yes. Does it look like f is increasing from 0 to infinity? Yes. Does it look like f has a valley or a minimum, local minimum at 0, 0? Yes. Does it look like f has a local max or a hill at negative 2 comma something? Yes. So you see what we're doing? See what we're doing? We're finding all the important stuff on f on paper and pencil using calculus. And that's one valuable thing that calculus does for us. Derivatives tell us a lot of what we want to know about f. And eventually I'm going to make you draw these by hand in the near future. Got it? Based on this plus stuff we're going to learn next time in section 4.3, day 2. On what? Wednesday is the next time I see you guys? Okay, so see what we're building up to? Eventually you guys are going to be as powerful as your graphing calculators. That's right. Okay. All right, so ready, guys? All right, now don't panic when you see trig functions. I know you guys do. Please don't panic when you see trig functions. Ready? Okay. As long as you know your unit circle, you should not panic when you see a trig function. Do you guys know your unit circle? What? Don't lie. I know you do. Okay. Okay. Oh, I will tell you a quick funny story. My first grader obviously went out last night, kindergarten. I'm sorry, he's in first grade, not kindergarten. And he went trick-or-treating, and when he got home, he said, Dad, I want to count my candy. So he's over there on the floor. He poured it out. He's counting his pieces, and all of a sudden he asked me, he says, Dad, what comes after 1,000,000,009? Thinking, okay, well, if you can count that high, how do you not know what the next number is? Okay. Okay. Anyway. Okay. So, back to the problem. I thought that was funny. I wanted to share that with you guys. Okay. So, don't panic, right? The derivative is actually pretty easy, isn't it here? What's the derivative here? Real quick. What's the derivative sign? Cosine, and then plus, what's the derivative sign, or cosine? Negative sign. Okay. So anyway, that's my derivative, right? All right, now, so we need to now figure out, when is this derivative 0 or undefined? Well, is our cosine or sine ever undefined? No. So this difference will never be undefined, will it? No. All right. Will it ever be 0? Well, maybe. And so what I want to do now is set it equal to 0 and solve it in some way, somehow. Okay, well, you might want to leave it like that, or you might want to, move one of them to the other side. So if I add sine to both sides, don't I get this? Okay, and by doing that, it kind of helps me kind of focus on what I need to do here. Don't I simply need to think of the unit circle and think about what angles the cosine equals the sine? All right, now hold on a minute. Why do you think I gave you an interval here where I didn't give you an interval on the other ones? Yeah, don't cosines and sines go on forever? And so if I didn't give you an interval, you'd never finish, would you? No, you'd be doing it the rest of your life. Okay, so anyway, so on the trig ones, we have to give you an interval. Agree? Yes? Okay. All right. Yeah, so otherwise there'd be an infinite number of hills and valleys, right? Which you could never find all of them. Okay. All right, so anyway, so that's good. So I only have to go around the unit circle once and look for the values of angles x where the cosine is equal to the sine. Well, where would one place be? Pi over 4, because sine and cosine are both square root of 2 over 2, and right? And in the first quadrant, sine and cosine are both positive. Okay, where else? Yeah, in the what? Third quadrant, isn't there where sine and cosine are both negative? Yes? And so you'd have the same reference angle, wouldn't you? And by the way, so one angle is what? Pi over 4, and what's the other angle? 5 pi over 4, everybody agree? Yes? Okay or not? Okay? Okay. All right, so back to the problem then. So f prime is what again? Cosine minus sine. And again, that'll be 0 at pi over 4 and 5 pi over 4. Ready? Okay, so here we go. So I'm going to start at 0 since I'm having the interval 0 to 2 pi, and I go from 0 to which one of those do I run into first? Pi over 4. Everybody see what we're doing? We're just kind of stretching the unit circle out onto a number line, so to speak, right? And then pick up there and go to what? To what? 5 pi over 4. And then from pick up there and go to what? Pick up there and go to 2 pi. Okay. Now, be careful. Make sure you pick angles that you know the trig values of. Otherwise, you're going to be stuck. So what angle between 0 and pi over 4 do you know the trig values of? Pi over 6. Good choice. Okay, pick something nice between pi over 4 and 5 pi over 4. There's lots of nice things. Pi is okay. Good. Pi is nice and easy. Okay, how about something between 5 pi over 4 and 2 pi? 3 pi over 2 is nice and easy, isn't it? Okay. Almost as easy as pi. Almost as easy as pi. Okay. Very good. Okay. Good point. Okay. All right, so now look. So what are we going to do? Where are we going to put that? We're going to put it into what? We're going to put pi over 6 into what? F prime. So f prime of pi over 6 would be what? Cosine of pi over 6 minus sine pi over 6. And what is that? Square root of 3 over 2 minus what? 1 over 2. And isn't that bigger than 1? So if that's bigger than 1, then that minus that will make this whole thing what? Positive. Everybody agree this whole thing is positive? Because square root of 3 is like 1.7, and so 1.7 minus 1 would be a positive number. Everybody agree with that? Good or not? Okay, so f prime is positive on that interval. And what can you say about f then on that interval? F is what? Increasing. Okay. By the way, can I show you another little trick on that? You want another little trick? Suppose you didn't know those trig values. Just suppose. Let me show you another way you could answer this. Ready? At pi over 6, here's a unit circle. Right? This is 1, 1, all that, right? Negative 1, negative 1. At pi over 6, which is like 30 degrees, right? What do you notice? Yeah. Yeah, wait, first of all, isn't this point cosine of theta comma sine of theta? And so at 30 degrees or pi over 6, are you further over or are you further up? You're further over, which means what? That is greater than what? Than that. And so when you look at your derivative, if cosine is greater than sine, won't that minus that be positive everywhere in there? Won't it? Yes? You see how I can do it without knowing the values? You will need that at some point in here. I don't remember what problem, but it's one problem either on the homework or on the test. It's probably on the homework, but just know that in case you need it. Is that clear? Yes? And that way you don't even have to find the values. That'll save you some time, won't it? Okay. All right. Put a pi in here quick. You can do this in your head. Put a pi there and a pi there. What's the cosine of pi? Negative 1, and then what's negative 1 minus the sine of pi? Well, the sine of pi is 0, so what's negative 1 minus 0? Positive or negative? Negative. So f prime is negative here. Everybody agree? And so if f prime is negative, what is f? Decreasing. Okay, put a 3 pi over there. Again, you could do it in your head. What's the cosine of 3 pi over 2? 0. Minus, what's the sine of 3 pi over 2? Negative 1. 0 minus negative 1 turns into 0 plus 1, which is definitely positive. Okay, if f prime is positive on an interval, what can you say about f on that interval? It's increasing. Okay, ready to go now? Ready to finish up? Okay, so let's start down here. On what intervals is f increasing? Quick. 0 to pi over 4 and 5 pi over 4 to 2 pi. Everybody agree? Okay, on what intervals is f decreasing? Quick, quick, quick. Yeah, good. Pi over 4 to 5 pi over 4. All right, let's go to here. Where would f have a local max? Well, let's just look at it. Look at the table now. What happens here? F goes from what? Increasing to what? Decreasing. So it looks like f would have a hill at what? Pi over 4, and hills are local maxes. So at pi over 4 comma something. And how do I get the y value? Plug it into where? To the original? Yes? And so, what is f of pi over 4, guys? Hold on one second. Well, yeah, that would be square root of 2 over 2 plus what? Square root of 2 over 2, which is 2 square roots of 2 over 2, which is just what? Square root of 2. Everybody agree it's just square root of 2 here? So you're talking pi over 4 comma square root of 2. Everybody agree with that? Okay, and then what's happening over here, guys? F goes from what? Decreasing to what? Increases. It looks like f would have a valley or a local min at what? 5 pi over 4 comma something. And so if you stick 5 pi over 4 into the original function, I believe you get negative square root of 2. You can check me on that. Okay, guys? Good? All right? Any questions? Okay. All right, now the rest of it isn't too bad. It's not a lot of work. It's just a lot of thinking. Okay, now I'm going to warn you about something. And you guys, you better look for this in the homework tonight. You better look for this on your next test. And you better look for this on the AP test. I want to go back to the very first page. Everybody up here. All eyes up here, please. All eyes up here. Everybody. Chris, please. What is this? This is a graph of what? This is on your very first page, right? Back to the first page. So if I give you a graph of f of x and start asking you where f is increasing or decreasing or where f has the hills and valleys, it's very obvious, isn't it? Okay, what I'm going to do now is I'm going to totally change things up on you. And instead of giving you a graph of f, I'm going to give you a graph of f prime. So I'm going to give you a graph of f prime now. Okay? I'm going to give you a graph of f prime. Wait. But I'm still asking you about the graph of what? F. So you're going to have to all be able to look at a graph of f prime and tell me all about the graph of f. Are you ready? Yeah. You ready? Yash, you ready? Yes. Get it? Okay. Okay. Ready? So again, everybody look at this graph of f prime. And I want to know, on what intervals is f increasing? So looking at a graph of f prime, you'll be looking for what? To see where f is increasing. Wherever f prime is what? Positive. What do I mean by positive? I mean above the x-axis. So everybody agree that f prime is positive in here because it's above the x-axis? Everybody agree that f prime is positive in here because it's above the x-axis? Same thing in here? Yes? Do you agree at everything I highlighted in green, that's where f prime is positive? Okay, so f then would be increasing what? From what? Negative 5 to what? Negative 2, and then again from what? Negative 2 to what? All the way to 1. Yes? From negative 2 all the way to 1? You agree that that's where f prime is positive, so that's where f is increasing? Everybody see what I did there? Yes? Okay, now, I want to know where is f decreasing. So what am I going to be looking for there? For when f prime is what? Negative. In other words, below the x-axis. Okay, so where is f prime below the x-axis? From 1 all the way to what? From 1 all the way to what? 5. So on the interval 1 to 5. Everybody agree? Yes? Akil? Okay? Yeah? Okay or no? Okay. All right, now, let me ask you this. Where would f have a local max or a hill? Think about it. Where will f have a local max or a hill? Whenever f prime does what? Whenever... Yeah. Hey, please put that away. You're missing a lot of good stuff here. Please. Let me ask again. What would you be looking for to find where f has a local max, or a hill, in other words? Whenever f prime does what? Changes from... Whenever f prime changes from positive to negative, that's where f will change from increasing to decreasing, causing f to have a hill. So again, to answer the question, f will have a local max whenever f prime changes from positive to negative. In other words, from where? Above the x-axis to below the x-axis. And where does that happen? At x equals 1. Everybody agree at x equals 1? F prime changes from above the x-axis to below. In other words, f prime changes from positive to negative. Does that make sense? Causing f to change from increasing to decreasing, causing the hill on f. By the way, why do you think I didn't give you the y value? I don't know it. I don't have a graph of f. I only have a graph of f prime. So all I can pick out is the x value of the hill. I have no idea what the y value of the hill is. Is that clear? Don't go giving me the y value from f prime. No. That would be wrong, wouldn't it? Is that clear? All right. And finally, to find where f has a local min, what would I be looking for on f prime? I'd be looking for f prime going from what? Negative to positive. In other words, from below the x-axis to above the x-axis. Does that ever happen here on the graph of f prime? Does this f prime ever go from negative to positive? In other words, from below the x-axis to above? No. So f has no what? Local mins. Okay, I would like everybody to try example 7 now. Again, I'm giving you a graph of f prime, and I'm asking you about f, aren't I? Yes? So give that one a shot, guys. Yeah, I'm giving you a graph of f prime, but I'm asking you about f instead. We'll be done in about 5 minutes, guys. Right? Again, you guys try not to miss next class, because you're going to learn a couple new tests, and it's going to be very easy to mix everything up if you miss my lesson. So please do not miss next time. Better not be senior skip day.
Senior skip day was today.
I don't want to hear that.
We're all here though.
What?
Senior skip day is today. And Monday.
Oh, it was?
And Monday.
No such thing.
So we have class next week, Wednesday, Friday. What are we thinking about a test?
What's that?
We have class Wednesday, Friday, so test is Tuesday.
Yeah, that's right, because 3day 2 is Wednesday, and that's it. And then Friday's a review, and the following Tuesday's your test, right? Okay. Ready, guys? Okay. Ready, guys? Okay. You guys, looking at a graph of f prime, f will be increasing whenever f prime is what? Positive. So that would be from 3 all the way to what? All the way to 0. So everybody agree? From negative 3 to 0. And where else? From 4 to maybe 5. I don't know if the graph keeps going, so I'll just assume it stops because I don't see an arrow. So from 4 to 5. Everybody agree with that? Yes? Okay. Where is f decreasing? Whenever f prime is what? Negative. In other words, below the x-axis. So that would be from what? Negative 4 to negative 3. Anywhere else? Yeah, from 0 all the way to what? 4. Okay, now, where will f have a local max? Whenever f prime does what? Changes from positive to negative. In other words, from above the x-axis to below. Does that ever happen? Yeah, where? At 0. Anywhere else? No. Okay, now, where does f have a local min? Well, that'll happen when f prime does what? Goes from negative to positive. In other words, from below the x-axis to above. And where does that happen? There at negative 3. Anywhere else? At 4 as well. Any questions? Okay, we have one more. And I'm telling you right now, you guys, any time I put a calculator problem in my notes, you know I'm going to put it on my test, because this is the kind of thing you're going to have to do on the AP exam, right? So you know I'm going to ask you guys to be able to do something like this on the test. I guarantee it. And this is the only one like it I'm doing. So make sure you get this. Ready? Make sure you're in radian mode, by the way. Okay. All right, so I'm going to start by hitting Zoom Z Trig, right? So in the Z7, right? All right, now wait. I only want to be on what interval? I only want to be on the interval what?
0, 2.
Wait. What's the interval? Negative 2 to 1. Okay. I don't know where that came from, but that's okay. Okay. Are we good, guys? All right, now hit graph. I'd like to get a little bit better picture, right? And so I definitely want to increase my Y max, right, to get a better picture of this. Let's try 10 for my Y max. Maybe a little bit more. It might. I mean, I just want to see if it's going to go up and come down. It probably won't change. I just want to make sure I have a really good picture of my graph. Okay? All right, that's good, isn't it? All right, now, you guys, if this were a free response question and you wanted to use the graph on your calculator to explain your answer, you'd have to copy this graph onto your paper. Otherwise, they're not going to know what you're talking about, are they? Okay. And so you're going to have to copy this onto your paper. Okay, so, sorry guys, so it's going to look something like this, right? Okay, now, aren't I going to need these x values for this type of question, aren't I? And how do I find those x values, guys? How do I find those x values? How? And by the way, label this as f prime so they know what you're talking about. How am I going to find those x-intercepts, guys? How? Yeah, the easiest way, there's a couple different ways, but the easiest way is to shoot a line across at 0. Because then you just do what? Second, trace, intersect, enter, enter, enter. It's pretty easy, yes? What is that? Negative 0.597, yes? Notice I always use 3 decimal places. That's what they want you to use on the AP exam. Always use 3 decimal places. All right, do it again. Second, trace, intersect. Enter, enter. This time on guess, you move over to this one and hit enter again. And so that one is 0.373. Okay, good. So once you do that, you can just put your calculator aside and now answer the question. So what do you think, guys? What do you think? Looking at that graph of f prime, on one intervals is f going to be increasing. F will be increasing whenever f prime is what again? Positive. So that would be from what? Negative 2 to negative 0.597. And then again from what? 0.373 to what? To 1. Okay, guys? And then where will f be decreasing? Whenever f prime is what? Negative, and that would be from what? Negative 597 to 0.373, right? Okay, now, I want to know where will f have a local max or a hill? Where? Whenever f prime does what? Changes from? Okay, so again, f will have a local max or a hill whenever f prime does what? Changes from positive to negative. Doesn't that happen right there? And finally, f will have a local min whenever f prime does what? Changes from negative to positive. And that would be at what? 0.373. Okay, now I'm done, but let me say one thing about your homework. Obviously, you have some book problems, but you also have these two problems where you need to figure out, okay? You see these three graphs? One of them is f, one of them is f prime, and one of them is f double prime. Now, I think you'll have no trouble figuring out which one is f and f prime based on what I taught you today, but how are you going to deal with the f double prime? Well, let me remind you about something. Anything I ever teach you this entire year that relates f to f prime can be used in the same exact way to relate what? F prime to its derivative, which is f double prime. So, for example, you know that whenever f is increasing, its derivative f prime will be what? Positive, and vice versa, yes? Well, whenever f prime is increasing, its derivative will be what? Positive, and vice versa. So, you see what I'm getting at? So it's really not a big deal if I throw f double prime in the mix, is it? It's not a big deal, is it? No. Got it? Okay? All right. And so let me ask you then, where will f prime have a hill whenever f double prime does what? F prime will have a hill. The graph of f prime will have a hill whenever f double prime does what? Changes from positive to negative. In other words, from above the x-axis to below. Does that make sense? I mean, that's not that bad, right? To translate it to f double prime, is it? Okay.